So hello everyone. Today we are going to solve few questions from Code Chef round not Code Chef, Codeforces round 723. So the first question here is mean inequality. So the first question is mean inequality. So in this question we are given an array A of 2n integers, two and distinct integers. The word distinct is important, and our essentially our task is to find a permutation B of A uh, such that any number is not equal to any number in this permutation is not equal to the average of its adjacent number. So example, suppose we are given the array 1 2 3 4 5 6. So I can arrange it as 1 4 2 5 3 6. So in this arrangement we can see that none of the numbers. So if we take 4 cannot be average of 1 and 2. Then we take 2 is not average of 4 and 5. So we have to find a permutation like this. So in order to solve this question, this question is pretty much simple. All you have to do is uh, sort the given array, a dot sort the given array, and after that what we can do is, after sorting, what we can do, since we have the number n and we have two n elements, take the first element and take the n plus 1 element, and so basically we write ith element and n plus ith element and keep on doing this. So basically we write first element, and over here, considering this case, we'll write the first element, we'll write the third element, then we'll write the second element, then we'll write 2 plus 3, that is fifth element, and so on. So how does this ensure our given condition? So basically, we know that n plus ith element will be strictly greater than uh, ith element and I plus 1th element, which are going to be its neighbor. So their summation can never be its average. And on the other hand, ith, ith element uh, will always be greater than n plus, always be less than, strictly less than both of this n plus I minus 1th element and n plus ith element. So their average can never be equal to this number. So using this we can essentially solve this question. Now for the next question we have here is, I hate 1111. So in this question we are given an integer n, and we have to determine whether n can be expressed as a sum of 11 uh, 11 or 111 plus 100 and 1111, and so on. So in order to solve this question, we have to jump to one. We have to see few observations. First observation is, now n can be written as the sum of 11a plus 111b alone. We can ignore the rest of the numbers because 1111 can be is divisible by 11. So essentially, and also we can use any numbers any number of time. So this can be expressed as 11 into 101, and similarly 1111 can be expressed as some combination of 111. uh, this can be expressed as some combination of 111 plus 11. So basically all these numbers which we have can be expressed as sum of 111 and 11 can be written in this format. Okay, so this is our first observation. So essentially we have to check that whether n can be written as 11a plus 111b. Okay, so now what we are going to do, so if we write 111a plus 11b, and now let's open this expansion, we get 100a plus 10 times a plus b plus 1 times a plus b. Essentially we get 100a plus 11a plus b. Now what if we write a is equal to some a slash 11, a double slash 11 times 11 plus a mod 11. So basically I write a as some number multiplied by 11. So basically I wrote it in the term of a divisor I wrote it in the form of a dividend is equal to divisor into quotient plus remainder. Now, one thing which can observe from this is that if we write a in this format, so what we'll get 100 times some number divisible by 11 plus 100 times a number k is less than equal to 10 plus 11 times a plus b. Now these two numbers are divisible by 11, so basically we can jump to the conclusion that if we subtract uh, 100 some 100k from our given number, and if we find that number divisible by 11, so essentially we can say that our number uh, n, which we chose initially, this number n can be expressed in this format. Now there is one more thing we need to take care of, that is a is greater than equal to 0 and b is greater than equal to 0. So for our observation over here, this a should be less than equal to a plus b, because b cannot be negative. Okay, so now now what we are going to do is, uh, when I tried this question, I didn't I didn't take it into consideration this case. So what essentially happened, my answer went wrong at the test case 211, because what I was going to do, what I was doing, I has to take my number and subtract 100 and check whether that number is after some point of time, is it divisible by 11. So when I subtract 211 to twice, I get subtract 100 from 211 twice, I used to get 11, which is divisible by n. But the thing is, I would require for for this to be true, I have to take b is equal to -1 over here. So that's why my answer was coming wrong. So after this attempt, I looked into something else, that if my number is greater than 1000, if my number is greater than 1000, then what happens is, this subtraction of 100 actually ends up somewhere being so this subtraction of 100 leads to at least one number where n minus 100k is divisible by 11. So due to this, what happens, any number greater than 1000 can be expressed in this form. Any number n greater than 1000 can be expressed in this form. So basically, for every number greater than answer, our answer should be yes. And now basically now we have to make uh, a table of size around 1000, or for safety 1000 plus 5, and we have to check whether that number is expressible in this format. In order to do this, we'll make an array. We'll make an array of size for safety, we'll just make it of 1100. And what we are going to do, okay, 1101, so every number from 0 to 1100 will be covered in it. And what we are going to do, we'll write dp of 0 is equal to true. And after that, after every number, we'll check if I is greater than 11 and I minus 11 is equal to true, and I minus 11 is equal to true, then dp of I is equal to true. And if I is greater than 111 and I minus 111 is true, dp of I is equal to true. So basically, if this is very straightforward logic, that if I minus 11 is true, that is I minus 11 can be expressed in this format, then I can also be expressed, and similar is true for I minus 111. So basically, I will get a quick lookup table of size 1100, and I know for a fact that after any number greater than 1000, or in for our safety purpose, any number greater than 1100 we will have to return yes, due to my explanation of my logic over here. And for the rest of the numbers, we can straight away check through our lookup table, and our answer is done. Okay, so that's it for today.